How's it going, everyone? Welcome, Julian Gonzalez. That's right. Today, let's go to explore now the function arguments adapters and how this is part of the functional programming POV, the perspective of how now engineers are using this functional programming approach to write their code is now quite access of the shape of the function. So that's why we, in this particular course, we understand now, or we understood, what is the function, the difference between a function and a procedure, and how this stuff actually fits into our narrative of the functional programming. In other words, since this is a course taught by Kyle Simpson, so shout out to Kyle Simpson, and he have now a book called Functional Like JavaScript, where the idea here is to understand now the conceptual and practical approach of this particular way of writing codes, where the value proposition of this is that unlike the imperative programming, which is we tell the computer what to do exactly, right? And most of those courses out there teach you this stuff from the top bottom approach. So they have now they sit on their ivory tower and they teach you all of these concepts, assuming that you already know all of this stuff. It's pretty much like a rock climbing, which is an example that Kyle Simpson actually used for that. Which is, if you're gonna do that and you're new to this, so there's some couple stuff that you don't know. So for example, pass me the carabin and all the other tool set, and you don't know what it is, and you have to figure it out quickly because you need to actually do the rock climbing. So similar to that, you go out and try to do this climbing. Now the approach here is from this bottom up, where is what are the things that we are used to do, and then slowly but progressively we're gonna integrate each one of them. And I think this particular approach is something that is the way how we learn stuff. Okay, so we start with the basic and then we start slowly but progressively adding stuff until we reach to more complex stuff. So for example, in the language, you're starting with the vocals and the letters, and then try to create sentence, and this sentence try to now read and understand and extract the main idea behind that until you are able to create at least now some essays or poetry. All right, this is from the language perspective. Or if you go into mathematics, it's like, hey, you need to at least know is the numbers, what these numbers are, what they mean, and what they represent, and also the operations, the arithmetic, right? The art of counting. So addition, subtraction, multiplications, and divisions, and then you now move to what we know as the algebra, or these broken pieces, and how all of these different broken pieces joins together in an equation, and then you started to see more and more and more. But the thing here is that all of this particular knowledge is going to stack up until you are able to get much more things done. So this is quite similar the approach here, where the functional, or at least in this course, is teaching us is what we are. So what are the things that we are quite familiar as a JavaScript developers, all right, or as software engineers, that we know how to do this stuff in an imperative way, and what is the value proposition of using now functional programming. The TLDR is that if we have a huge code base where 80% of that is laid out on mathematical fundamentals, so we are sure that that worked the way it is supposed to. We can look at the other 20% of the code that is not, or that causes this uncertainty. Okay, that our level of confidence is low, pretty much like business logic, right? Which is, of course, is constantly changing. So this is the value proposition of the functional programming, as well as so while we are doing this and following certain concepts and rules, now we have a huge code basis that is provable and also easy to, and as a byproduct, which is another thing, as a byproduct, it is easy to understand, reason about, think, and improve and fix. So that's why we first explored about what a function is, but first is to at least understand what are the things that we're going to see along the way. So introductions, the function purity, the argument adapter, the point free. These two concepts is something that we're going to talk in today's video, as well as the closure. But I think this is for another video. But in any case, is function purity, the arguments adapters, point free, closures, closures, composition, immutability, recursion, list operations, transduction, something that we barely know about this, data structure, operations. Here is when it comes concepts like monoids, all right, in this weird data structure. This is not that weird, but this particularly this peculiar name called monoids, right, and endophunters, and that kind of stuff. So you have now these data structure operations, which is, for example, Redux. This state management allows us to handle that this different state. They have a version control of this, and then we have now the async. How can we deal the async in a functional way, using our promise and the observables, functional JavaScript utils, which is Lambda, Lodash, and all that kind of stuff. So this is just to describe that in this particular journey, something that I mentioned before, we're gonna hit the pit of despair at some point, but after we pass it and then we keep pushing to see what is the value that we can get to apply in our code bases for our clients, then it's going to improve now readability vastly. So in any case, that's why we went through first understand the difference between functions and a procedure. And a function is just as the name suggests, is function, but it receives a input and it returns a computed output. So a function is the relationship between the inputs and the computed outputs. Okay, so what are these particular relationships when you define that? And that's why it is important to, unlike procedures, that they don't necessarily return something and also modifies the state of our application somewhere else. Okay, functions does not do that, and in fact, this is the reason why function purity is so important, at least here, as a way to have now our code provable, as to make now the code easy for us to understand, and easy for us to understand, and therefore to debug, fix, and add features. So this is known as there are certain couple stuff that we need to do to make these functions pure. All right, and that is recognized to eliminate side effects or anything that modifies the state of the application outside of this scope. right? So this side effects or this functional stuff, particularly the function purity, is to recognize that yes, if you want to have certainty in something, you need to make similar like a unit test. When you pass everything that this component and function needs to, this is now pretty much what function purity means. And sometimes you cannot, or you will have to have some sort of side effects, because anything that generates CPU heat, for example, you need to wait for that something to compute, perhaps some huge data set that you need to transform into some sense, or you need to wait for something to be completed. All right, anything that generates eventually CPU heat or CPU time delay. A couple examples here is that network operations, you're waiting for that to read to the database, or the DOM, or to read for a local file, or to calculate random numbers. Okay, that's another, or timestamp, right? So network call is another one. So all of these particular side effects, at the end of the day, we eventually have to do that. And as a JavaScript developers, at some point, inevitably, because otherwise this sharing documents across different computers wouldn't exist. Now, so sometimes when we are writing our functions in a pure way, we need to recognize that a function pure is something that, well, is actually now give you the same input and the same output. All right, so no matter how many data points you pass here, and data points is the arguments of this. They recognize the parameter as the arguments. We're going to talk about that in what arguments and parameter means. But here is that, well, these two parameters that is going to receive now have a close relationship to this, and also they are not going to be reassigned at some point during the function execution, which is this particular stuff. So we don't know what C is, all right? And however, if we expand that a little bit and we say, hey, we know that C is a const, and therefore the entire add another functions becomes pure in this sense, okay? Because function purity, what we want to do, even that if it has a var, because function purity is that it will give us now the confidence that whenever we have to run these functions, we reduce the surface of reassignment. It is arguments. Reassignment, it is parameter to a new argument. Okay, so what is this parameter and arguments? So parameters is now the inputs that we define in the function declarations here, and the arguments is the value that we pass when we call it. So this distinction here is crucial, because if you want to write now your functions in a pure way, the whole idea of this is that whatever those inputs that you're going to use, or that variable that you're going to use, we want this to reduce the surface of reassignment, therefore to introduce some side effects or some weird behaviors. Okay, so that's why we have now this particular pattern to say, hey, let's go to now reduce is the reassignment surface area. And why we're doing this in the function definition, this is important, is because at the end of the day, function purity matters for the color of the function. And that's interesting because it is also self-explanatory. It's quite duh, since you want this function to be run. So you want, when you're gonna use this function or these methods, you just want to make sure that this function works as it is. Okay, you don't want any weird behaviors, something that's going on behind the scenes, and that's why we have now this solid principle, especially from the object-oriented programming. Okay, single responsibility, open to extension, close to modifications. The least substitution, so a base client, a base class must have is the property and methods from the base class. The interface segregation, so instead of giving this huge gigantic options, so it's going to now segmentate that into small interface that the user, the consumers can go with. And the dependency inversion, so low level models should not rely or should not depend on high level models, or high level model should not be tightly coupled to low level models. All right, there must be a layer of doing that. So in any case, the point of here is the functional programming. That's what we really care. That's what really matters here. So the thing here is that with this, okay, reducing surface area, so functions add another, add two, and all that kind of stuff. But the thing here is function purity. At the end of the day, it focuses on the function definitions to reduce the surface area. So to reduce is the reassignment surface area, which is a great stuff, all right? But also from the color's point of view. So the function purity at the end of the day is just, so the value proposition of this is giving now a level of confidence when we write our code, because now we can rest assured that since this is going to based on mathematical proof, so pretty much like you don't need to actually understand the mathematical definitions or proof about 2 plus 2 is equal 4. Okay, so we just only use that particular tool to get something. Okay, and I think this is very interesting and powerful. So function purity is for code, not definitions. So what happens when, even though at some point we're going to have a side effect, so how can we now, well, create a function or extract the impurity of that function? So there are two techniques at least. One of them is the extracting the lexical scope, or I would like to use this particular term, is by containing the lexical scope and return a new copy of that. So for example, here, okay, in this particular example here, let me actually put it here, show me the entire file, review change, where is what if I want to look at the entire file, view file, that's right. So here we got now the students, all right, and the whole point of this is that these functions right now, let's go to assume that this is a side effect, which is indeed is doing now a side effect. By actually sorting is the global object data structure here, and then it's going to return that. Okay, so what we can do here is to say, hey, let's go to now contain the lexical scope so we can return a new copy of this. And that's pretty much what we did. Let's go to now hold the lexical scope here, and we're going to pass here and reassign that with a new copy. So copy the lexical scope and then return a new copy. Okay. And the other technique is the brute force And the other technique is the brute force approach, and that is, hey, let's going to now is take a snapshot of everything and then restore the state afterwards, which is here, that's right, and restore the state afterwards. Where it is. How can I get into this? View file. So is this one, the brute force approach. You say, hey, let's go to take the snapshot of everything. Okay, take the current snapshot of everything here, and here we're gonna now use is the sort by ID. So take a snapshot of everything and then restore the and then restore it afterwards. So in other words, we're saying, hey, instead of actually copy the lexical scope like this, all right, instead of copy the lexical scope here, we're saying is that let's going to take now a snapshot of this. This might not be good for almost any context, all right, especially if you are now loading. This can be quite expensive as well in terms of memory use, because let's say you want to take a snapshot of your entire database. That's not feasible. You know, you can take a snapshot of the particular slides of that stage or pagination, right? But for small data sets, like what we're going to handle is on JavaScript or any JavaScript based framework, React, Angular, Vue, React Native, yada yada, you name it. Okay. At some point we're gonna now build is this. Okay. And that's fine. And that's fine. So what we're doing is to say, hey, let's gonna take a snapshot of everything. Okay. And by taking a snapshot is to create a new copy of that. And this new copy in this function we're gonna pass. We're gonna be available in the lexical scope here. It's gonna be available in the lexical scope by the time that we call now that function here, source student by ID. Okay, so instead of calling is the global function, it's gonna call now the closest, which is now the student. All right, and then it's gonna give us the student sorted by ID, which is a good stuff. And we want is to now store that here with the new student and then restore the state afterwards. So in other words, you say, hey, let's go into now is to make the student's reference and restore that with the original student here, which is exactly what we do. It's like, hey, do you remember that copy? All right, I want you to now is I want you do you remember this copy here? I want you to blah, 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 blah. Yeah, do you remember this copy here? I want you to now yeah, do you remember this copy here that we cloned from the outside object? All right, well, now I want you to is restore that copy, make it that afterwards. Why this is important? Because now you're going to hold is the students to that. Okay. That's interesting. That's interesting here. So if you're creating these two copy here, and then you say, hey, now the new student's reference, which is a copy that you create here, you're creating these two copies here. So now you modify is this, and gonna give us now a new state of this, of the student in this case. Okay, which means that we change is the current student. All right. This local reference here, we modify is this local reference. Since we modify is the local reference, okay, and then we now going to send this new reference. I don't think that if you call this function again, you're gonna receive is that current state. And that's to me quite interesting here, because it's saying, hey, this, so the student, so after you run that, after you execute that instructions, okay, so this is the state of the student, but we don't want to make the state of the student like that. We want us to restore afterwards, which is with the original student here. With the original student here, reference. So this is student, okay. I think this is, okay. That is going to explore this. Yep. Impurity. Call a temporary state swap or a control side effect. On a global state student that exists outside of the function. Exactly. It needs to temporarily replace the global state. It needs to temporarily replace the global state to perform an operation. After performing the operation, exactly, replace or create a copy is here. It needs to temporarily create is a copy, a local copy of this current student that you're passing here. And after performing the operation, it restores the original state to avoid contaminating the global state. The issue with this approach is that it is manipulating a global variable is a side effect, which can lead to unexpected behavior and bugs. The function stored by student ID likely relies on the global student rather than the taking parameters. So let me actually give you a little bit more of context. Let me give you a little bit of context. Okay, so let me give you a little bit more of context. Yeah. Is being used to address a side effect issue caused by source student by ID function. Let me explain what happened. The problem is that source student by ID is modifying the global student array instead of working purely with parameters and return values. So far so good. This design means that every time source student by ID is called, is permanently changing the global state. So far so good. Here is why the state restoration is needed. The comments say don't modify this function so we can change sort by student to make it pure without side effects. Okay. Since we can modify sort by student, the get student by the function save the original state by copy the original student, exactly, temporarily replace the global array with input array student, or in other words, is creating now a local reference of this function students here, okay, with this current student that we're getting as a parameter, and then call source student, which source the global array. Really, it is sorting the global. Really? Okay, I don't know JavaScript. Really? Really? Call source student by ID, which sorts the global array and returns it. Restore the original global state student to the original student. This pattern is sometimes called working around impurity. The function needs to temporarily replace the global state, but why is this? But sometimes you can redesign, my friend, a function. You have to work with what you have, you know. Call source student by ID, which stores the global array and returns it. Restore the original global object student is equal to original student, so yada yada yada. But this pattern is sometimes called working around impurity. But since students have a new copy of the yes, but since the student has a new copy of the array, current student, okay, but since the student have a new copy of the array current student, by the time that we call get student or source student, which is that, so by the time that we call source student by ID function, the function lexical scope of student wouldn't be the current state, wouldn't be the reference, wouldn't be the copy of the current student that we store in the student variable. You know, the key insight is that sort by student by ID isn't using local variable name student within its own lexical scope. It is directly accessing and modifying the global student variable. Here's the sequence. Oh my, why is this? So by the time that you call this function source student by ID, okay, so if for some reason we return if for some reason we return it's because we are calling that. That's interesting. So my gap here is this. When you create variables inside of a function, in those variables in one, when you create a variables inside a function, for example, student, for example, like this. So you have the function get student, you say student, so say get student by ID, you say get student by ID, and then you say current student, say student, you say current student, right? And when you create this, okay, so when you create this, say, hey, it's going to say students. There will be now a new copy of this current student, okay, like this. And if you there is a difference here between function definition and function execution. Oh my god. There is a thing here. Okay, I know. I identify my gap here. Function definition and function execution have a different scope, bro. So function student by ID current status, say, hey, student current status, current students, okay, like this. And by the time, if you define a function here, all right, you can have access to, but because you are calling a function, function definition and function call. Oh crap. All right. And then you have now this another function here called, let's say, function sort by ID. All right. And this function sort by ID. So when we create a variable inside a function for example, like this. Isn't the student reference inside the isn't the student reference inside the sort student by ID? So isn't the student reference inside the sort student by ID when we call it in get student by ID, the new array from current students? I see where the confusion is coming from. Let me clarify how variable scope and reference work in this case. In JavaScript, when you use a variable without declaring it with let, const, or var within a function, as is your example with student, you are not creating a new local variable. You are assigning to a global variable. Really? you assign into a local variable. Let's break down what's happening in this example. When you write student, current student without a declaration keyword like let or const, JavaScript JavaScript is looking for an existing variable name student in the current scope, and if it doesn't find one, it goes up the scope change. If it still doesn't find one in any parent scope, it creates and modifies the variable in the global scope. In this, so let's going to put this a test, bro. Jesus, let's going to put this a test. Absolutely. Let's say, hey, function. Okay. How are you gonna put this test? I'm gonna create this function and see if we are modifying is this reference. Yeah. I want you to create an example with a small data set to recreate it so I can learn about it. So if I do this, all right, and then on the console I'm going here and say, hey, you know what, no, come on, allow pasting. You're so fucking annoying. Allow pasting. There, you got it. Okay. So this is our global array or student. Here, this function directly modify and return the global student. Exactly. And return the student. So far so good. So this function restores the state to avoid permanent modification on the global array. Get student by ID. Save original state, original student, and temporarily replace the global variable here. Sort that and restore the original state afterward. Let me run this code here. So this example here is say, hey, without state restoration, this is the global object. Inside sort student by ID, inside sort student by ID, and the global students are now this. With state restoration. Oh, because it's doing all of that, it already performed that stuff as it is. Save the original state, temporarily set global. Okay. Using global student, sort student by ID after sorting, and sorted result, and after restore. But the thing here is that my confusion is between function execution and function definition. JavaScript look for an existing variable named student in the current scope. Exactly, in the current scope. If it doesn't find one, it goes up the scope change. If still doesn't find one in any parent scope, it create and modify the variable scope, the variable in the global scope. So in this case, get student by ID, execute student current status. It is modifying the global student variable. When sort by sort student by ID reference students, it is accessing the same global variable. Both functions are working with the same global student variable, not separate variables with the same name in different scope. Both functions are working with the same global student variables. Okay. Not separate variables with the same name in different scope. If you want to create a local variable within get student by ID, you will need to use is a let or const. It makes a lot of sense here. Here we're using is okay. In this case, because we are what about in this case? The scoping behavior is different because source student by name is defined inside. Exactly. Is defined inside of this. And let me explain what's happened. When you define a function inside another function, the inner function have access to the variable from the outer scope, function scope. This is called a closure. Exactly. So here's what happening step by step. So far we are quite familiar here. This is an important difference from the previous example. Here the inner function definitions form a closure over its parent functions variable. So it is operating on a local student variable, not a global one. Both functions are working with the same array in memory, the copy creating in the student, but it's a local variable to get student by name, not a global variable. So the scope change happens at functions declaration, not a function. So the scope change happen at nested functions declaration. Okay, so the scope change happen at nested functions declaration. Okay, so the scope change happens at nested functions declaration. Yeah, so the scope change happen at nested function declaration as it is, not when you run a function inside of a function declaration, right? That's exactly right. The scope change is established at function declaration time, not at function execution time. This is fundamental concept in JavaScript called lexical scope. When a function is defined, declare it capture or close over the variable in its surrounding scope. This is what creates a closure. The functions retain access to this variable even when it is executed later in different contexts. To summarize the key point, in your first example, both functions were at the same level, likely global scope, and were accessing the same global student variables. That's what happened. So on the function definition here, I don't know JavaScript. Oh my god. Okay. All right. Okay. Jesus. So the closure or the close over is created at functions definition. This is known as the lexical scope. Exactly, lexical scoping. But the other is at function scope. This is why nested functions declaration have access to their parent function's variable. By simply calling one function from another doesn't give, but simply calling one function from another function doesn't give the call function access to the caller variables. How is this called, man? What is this called? The difference of lexical scope and variables. Accessing at runtime when calling inside of a function, and functions trying to access variable when calling inside of a function. And dynamic scope. This is known as static scope, and the other is dynamic scope. Will mean that the function have access to a variable from the scope where it is called, not where it's defined. This is the main issue here that we're trying to solve here. Okie dokie. Holy hell. Alright. So functions definition have lexical scope, which is good. You know what it is. So regardless the context that is being called, you're gonna get that. Awesome. But the other is dynamic scope. Is that those variables at runtime will mean that a function have access to variables from the scope where it is called, not what is defined. That'll be all for this video. Take care. Bye bye.